All right, here's our second example of graphing an ellipse from its equation. And so we're given here an equation, and we're asked to sketch its graph. Of course, the type of graph we're going to get is sort of given away in the statement of the problem because we're asked to find the foci, or the foci, of the graph. And so that implies that this graph is probably going to be an ellipse. But let me show you how we can easily determine from the equation that this is the equation for an ellipse. Remember, in the equation for an ellipse, it's of the form x squared divided by a quantity plus y squared divided by a quantity is equal to 1. But in this equation, the right-hand side of the equation is not 1. Instead, it's 144. But we can easily make the right-hand side of this equation 1 just by dividing every term in the equation by 144. And then when we do that, we can easily surmise that indeed this is the equation for an ellipse. So let me divide every term in the equation by 144. And so when we do that and simplify, since 16 goes into 144 9 times, I think, we end up with x squared over 9, which I'm going to write as 3 squared. And then plus 9 goes into 144 16 times. And I'm going to write the 16 then as 4 squared is equal to 1. And so here you can clearly see then that this equation is the equation for ellipse. We have x squared divided by a quantity squared plus y squared divided by a quantity squared is equal to 1. And that's the equation for an ellipse centered at the origin. I keep having to stress that we're looking at ellipses centered at the origin. In a later example, we'll look at ellipses that have been translated so that the center is not at the origin. So in this case now you see the quantity squared that's divided into the y squared term is 4, and that's larger than the quantity squared that's divided into the x squared term, which is 3, of course. And so that means then that this ellipse is going to be elongated along the y-axis. The y-intercept is 4. The x-intercept is 3. And since that y-intercept is bigger than the x-intercept, that means that this ellipse is going to be elongated along the y-axis, or in other words, its major axis is the y-axis, and then its minor axis is the x-axis. That being the case, then we're going to label the 3 and the 4 slightly differently than we did in the last example. I'm going to write a squared is 4 squared. So in this equation, I have y squared divided by a squared instead of x squared divided by a squared. And then I'm going to write b squared is equal to 3 squared. So I have x squared divided by b squared. And so this is still the equation for an ellipse. The reason that I'm going to label the quantity beneath the y squared as a squared and the quantity beneath the x squared is b squared rather than vice versa is, remember, I want to preserve this inequality a squared greater than b squared, which implies that a is greater than b. But nevertheless, since a squared is 4 squared, that means that a is plus or minus 4, and since b squared is 3 squared, that means that b is plus or minus 3. And the 4 is still the y, still indicates the location of the y-intercepts relative to the origin, and the 3 still indicates the location of the x-intercepts relative to the origin. So we know we have a y-intercept up here at 4, and another y-intercept down here at -4, and then an x-intercept at 3, and then another x-intercept at -3. And since this ellipse is centered at the origin, then we can use the intercepts there to sketch the ellipse. I'll do that in just a second. I want to point out something that I said mistakenly in the previous video. The vertices of this ellipse are going to be the two y-intercepts. We won't call the two x-intercepts vertices, although they're somewhat analogous to the two y-intercepts. The vertices of an ellipse are the endpoints of the major axis of the ellipse. And the endpoints of the minor axis of the ellipse, they may have a special name, but I'm not sure what it is, but they're not called the vertices. So the vertices are just the endpoints of the major axis of the ellipse. I think I was calling these endpoints of the minor axis also vertices in the previous example, but that's not quite correct. Okay, so using the intercepts, we can make a nice sketch of that ellipse. Let's also determine the location of the foci or the foci of the ellipse, depending on how you want to pronounce that. And those foci are going to be located along the major axis, so in this case along the y-axis, because this ellipse is elongated along the y-axis. Its major axis coincides with the y-axis. But now we can still use the same equation that we've been using before to determine the location of the foci or the foci. C squared is equal to a squared minus b squared. So somewhat similar to the Pythagorean theorem in its statement, but slightly different. And so this tells us that c squared is going to be 16 minus 9, or c squared is equal to 7, which means that c is going to be equal to plus or minus the square root of 7. Let's pull up the calculator here and estimate the square root of 7. So here's the Windows calculator, and that's convenient for computing square roots. And let me see if I can find that. So let's type in 7, and here's the square root. So the square root of 7 is about 2.645, etc. So we'll round that off to approximately 2.6. So that means that the foci or foci are going to be located at 2.6 on the y-axis, and then also minus 2.6 on the y-axis. So about right there, roughly, and maybe about right here on the y-axis are the location of the foci. And now let's see if we can sketch that ellipse roughly. And I think I did a little bit better job in this example than I did in the prior example of sketching that ellipse. So there it is. Okay. So our two x-intercepts are going to be at 3 and 0. So those are the endpoints of the minor axis of the ellipse, which coincides with the x-axis. And then our vertices, the endpoints of the major axis of the ellipse, are at, oops, I put that, I did that right, okay, at 0 and 4, and then 0 and minus 4. And then here are the location of the two foci. One at 0 and square root of 7, and then another one at 0 and minus the square root of 7.